All right, so we're going to start chapter 7 or unit 7, whichever way you want to look at it, which is going to deal with chemical reactions, chemical reaction types, um, endothermic, exothermic, and also going to do a lot of work with balancing equations. So we're going to take our time with this unit, do a lot of practice to be sure we understand the process of how to not only identify what type of chemical reaction is occurring, but also how we balance those equations and why that matters. All right, so just a little bit of review, some vocab terms and some key concepts. So a chemical change, this occurs when one substance changes into another substance, okay? Keep in mind the difference between a chemical change and a physical change. The chemical change is the resulting product is completely different than what you started with. A physical change, you just may change the shape of it or the state of matter that it's in, but it's still at the end of the process, whatever substance you started with. All right, so the law of conservation of matter is something we need to review, and it simply states that matter cannot be created nor destroyed. It can only be changed. And that's going to be important when we start talking about balancing equations. Matter doesn't just simply appear and disappear. And you can change its form, you can change the type of form that it's in, but whatever matter you start with has to be the amount of matter that you finish with. Law of conservation of energy is very similar. It says energy cannot be created nor destroyed, it can only be changed. And that is important as well. All right, so chemicals reactions. These are going to occur when a substance undergoes a chemical change to form a new substance. In a chemical reaction, atoms are going to be rearranged as bonds are broken and new ones are formed. So in a chemical reaction, nothing's going to be lost or gained. Right? So that means the amount of matter you start with in the reactants is going to be the same amount of matter that you end with in the products. The form that matter is in may change, but the amount of matter is going to be consistent. And the same with the amount of energy. Atoms cannot be changed, or atoms cannot be changed to other atoms. That goes back to the atomic number of an atom being the atomic number of that atom, and that is consistent. So, therefore, all equations must have the same number and kind of atoms on both sides of the equation. And that leads us into why it is important to balance chemical reactions. Let's see. All right, so basically, long story short, this is what a chemical reaction will look like. You have your reactants, and the arrow points at the products. Um, this box should be over these arrows. That means it should be yields or equals or produces or forms. So the reactants are the chemicals that you're going to start with, and the products are what you end up with after the reaction occurs. All right, so some signs of a chemical reaction. Number one could be production of a gas. Maybe there's some bubbles occurring. Okay, bubbles are a great indicator that gas is being produced and given off. Production of a precipitate. What we mean by precipitate is some type of solid substance beginning to form in the bottom of whatever it is that you've mixed together. Maybe there's a change in color. Okay, the leaves changing from green to red or browns or yellows. That's a chemical reaction. A change in odor. Maybe it's giving off a smell, a distinct smell. Last, and one of the easier ones to see is the production of light. Okay, if it's putting off light, then that's a chemical reaction. Or you can put your hand on a certain beaker, and if you feel heat, then that's another sign that a chemical reaction is occurring. Energy and reaction. So all chemical reactions release or absorb energy. And this energy can be in the form of heat, light, sound, or electricity. So in order to break bonds, we've talked about this, in order to break chemical bonds, it takes energy. So you must put energy into those chemical bonds to break them. To form chemical bonds, energy is going to be released. Okay? So it takes energy to break bonds, energy is going to be released to form bonds. So this brings us to two very important vocab definitions. Okay? Endothermic and exothermic. So endothermic is when more energy is required to break the bonds than is released when new ones are formed. An example is photosynthesis. So endothermic, we have more energy that is going to be put into that chemical reaction than is going to put out. Okay, so into, endo, inside. Okay, more energy is put into that chemical reaction than what is given off. Exothermic is less energy is required to break the original bonds than is released when the new bonds form. All right, so an example is bioluminescence, which is the fireflies lighting up. So in an exothermic reaction, more energy is going to be given off than is brought in. Okay, exo out, outside, exit, more energy given off than brought in. Endo, into, inside, more energy is put into that chemical reaction than is given off. And this is a kind of a good little, we're not doing guided notes in this particular video, but this is a good little cheat sheet, so to speak. Endo is enter, heat enters and it feels cold. So an endothermic reaction is not going to put off heat. Okay. Exo, exit, heat exits, feels hot. An exothermic reaction sometimes is going to put off heat and it's going to feel warm. So that is the end of the first video for this unit. If you have questions, please let me know and be sure you complete the form that goes with this. Thank you.